In this question, we will find the inflection point. It is from the lesson 4.5. We have been given an equation and we have to find the concavity. Now, one problem I will do it properly using the concavity and everything. Other problems I'll directly tell you how to find the inflection point. Sadly, there is no calculator method for this because we have to double derive this given equation. What do we do is, as you see this equation, you need to derive it once, and that will be 3x power 2 minus 6x power 1 because it's 2 minus 1, and then plus 4. We have done this derivations plenty of times. Now it's not over. One derivation, we can do it in various ways, shortcuts and everything, but you cannot do double derivations in the calculator. So you have to do it manually. It will be 6x minus 6. That is dissolved. This is gone. Now what you need to do is, the second derivative, the double derivative of the given function must be equated to 0 and solve for x. So I'll directly put this 0 and we have to solve. Because it's not power 2, it's better to solve it directly. You can use a calculator as well. You can put the 0 equals 6x minus 6. But if it's quadratic or higher, calculator is necessary. But if it's only power 1, then directly you can solve this. Take the 6 to the other side and divide both the sides by 6. It will be 1 is equal to 6. So the inflection point is 1. Most probably this will be asked for exam. You will have 4 options of x. So x1 is your correct answer. But if you want to know the concavity, imagine this is the graph. X is equal to 1. Let me take it over here. Here it's until infinity, minus infinity. And let us take a test point less than 1. I'll take it as 0, and more than 1, I'll take it as 2. The double derivative, this equation must be used in the calculator and check what is happening. Here I'll just type this double derivative equation, that's 6x minus 6. I'll just show you. If you're wondering how to solve this in calculator, you just press equal to 0, and not equal to, you should press shift and solve, and then if you press equal to, the answer is 1. But now that is not what we are solving for. We are using this equation and testing it at 0. Calculate it at 0. What is the value? It's negative. What about positive value? If you calculate it at 2, here it's positive. So it's minus here and plus here. That means it's concaving downwards and upwards over here. So this is the concavity at the inflection point. So you can write x greater than 1 will be concaving upwards. Concave up, and otherwise it's concave down. Let's look at the answer, how they have written. You can see x1, that is the inflection point. That's the most important thing. Now f double derivative is greater than 0 means it's concaving up from greater than 1. That is 1 to infinity. X is greater than 1. That is 1 to infinity. It's concave up. Why? Because the double derivative of x is greater than 0. Whereas when it's less than, over here it was negative, right? It's concaving down from minus infinity till 1. That is how we solve it. But here mainly focus on the inflection point. I will try for solving all the other problems only at the inflection point directly. Whereas the concaving, you can just draw a small graph and check it out. Here what's happening, it's the same type. First derive once, that will be 4x power 3 minus, it is not 6, it will be 12 x plus 2. And double derive it, it is 12x power 2 minus 12. That's it. Now since it's power 2, I will use a calculator using mode phi 3. Quadratics, this is a quadratic, power 2, right? Just click on mode, and in equations, if you go phi, the third option is quadratic equations. What is before x squared? It's 12. But you can see there's no x term. Don't write it's minus 12 here. No, it's 0 because there is no x term here. And then minus 12. Here we go. The answer is 1 and minus 1. So there are two inflection points. X is equal to 1. X is equal to minus 1. Or plus or minus 1. You can write this. Anything can be your option, you know. Now, if you have to do the number line over here, remember there'll be minus 1, there'll be plus 1, and then there'll be 3 intervals. Then you can find which is concaving up and down. You can see the Over here, the answer is given as -1 plus 1. Here as well, we will quickly derive this problem. Now, how can we derive this? F of x will be equal to x, let it be, plus, I'll take this 1 by x, right? Upside, this x goes up, it'll be x minus 1. Now, let me derive it over here. It's going to be 1 plus this minus 1 comes down, and x minus 1, what happens? This is the first derivative. The first derivative will be 1 minus 1 is just minus, right? Because minus 1 means minus x minus 2. This is the thing. But we want double derivative. So when we double derive, this number is gone. It will be 0 minus 2 times x. Now I do not need to put this bracket over here, because minus 2, because there was a negative sign, I put bracket. It's minus 2 minus 1. So what is happening here? It'll be 0 minus plus 2x minus 3. Now then, this is a single term. 0, I'll just remove it out over here. This is the double derivative, right? Now make this equal to 0. So f double derivative is 0 is equal to 2x power minus 3. What is the answer? X is 0, right? Because right side is 0. This variable has to be 0 because this is a number. However, it doesn't matter what. You divide both the sides by 2. You take the cube root or anything. X will be 0 is the inflection point. Now here there's one important thing to remember. Whenever you have fractions like this, say imagine you have x power minus 3 and here you have anything, it should be either x or number. If you have x, or say like this plus 2, imagine this is your equation. When you double derive, this is going to be 1 and then a number, constant 0. This will be 0 at the first derivation only. So you're only remaining with this. You'll remain with x minus power 5. Then you're making it equal to 0. So no matter what, your inflection point will be 0 even for this problem. Directly you can tell. Because this is not there, only a single term. When it's equal to 0, it will be 0. The variable will be 0. So the answer is 0 here. What about this one? Now here, I can tell this is going to be 0, right? It's gone when you double derive. These numbers and all can be gone, but whatever is inside, right, it will be x is equal to 1. Directly you can tell this. So x will be equal to 1. Let me just check, because it's minus x. 1 minus x is equal to 0. Minus x to the other side will be x is equal to 1. See, this is the point of inflection, but let's solve it. What happens over here? When you first derive it, it's going to be 1 plus. Now here, 3 is a coefficient number. That is fine. But this is the power rule. So it'll be multiplied by 1/3. This power comes down. And then we have 1 minus x, the whole power, 1/3 minus 1. And then we have to solve this up. We have to multiply it with what? You have to multiply it with the chain rule. Whatever is inside, when we derive whatever is inside, it's just going to be minus 1. Because 1 will be 0, minus x will be minus 1. This is the power rule, this much. This is the chain rule. Whatever is inside, we also derive it. So first we derive the power and then we come inside. So if it was only x, it would just be 1, so we don't write it, but it's minus x, therefore we write it out. Now the first derivative is equal to 1 plus this 3 and 3 cancels off. I should have removed the plus. Why? Because it's going to be minus, right? There's minus 1 here. So it's going to be minus 1 minus x. What is 1/3 minus 1? It will be negative 2/3. You can just use your calculator for that. This is the first derivative. Now let's do the second derivative. When we do the second derivative, it's going to be 0 minus, and we'll have minus 2/3. 1, let me just remove that. 1 minus x. Now minus 2/3 minus 1. Here it'll be minus and minus is plus. So I'm just not going to write the sign. It's positive. 2/3 times 1 minus x. Okay, I forgot to write one important thing. After this, there is again the chain rule, minus 1. Don't forget that. So there's 3 minus and minus will become plus, and there is 1 minus remaining. So I will leave the negative sign. Okay, this is very important. It's minus 2/3, 1 minus. I mean, if it would have been very important if it's writing, but since now it's not writing, it's okay if you do this mistake as well. As long as you get the inflection point correctly, it's okay. Now this will be 3 by 3, it will be minus 5 by 3. That is all equal to what? 0. So this is all, a single term. So just this remains. You take everything else to the other side. Other side, you just multiply by the reciprocal of the power 3 by 5. Both the sides, it's 0 only over here. So then what happens over here? Minus 2/3. To the other side will be 0. So everything will be 0, and 3 to the other side will be 3 multiplied by 0, 0 divided by 2, minus both the sides, it will be 0 itself. So it's very easy, and what you're remaining exactly with is 0, 1 minus x. So x is equal to 1. That should be the inflection point. Since we know the left side is already going to be dissolved to a constant 0, we can directly look inside the brackets and tell x is 1. That's the point of inflection. Now we have trig functions, sine and cosine. What is the first derivative of sine? Sine is just cosine. It's cosine x, positive. But what about cosine? It's minus. Already there is minus, and then minus sine x. So here we have to multiply the two negative signs. It's going to be cosine x plus sine x. That is the first derivative. I'm going to do the second derivative here. The second derivative is going to be cosine becomes minus sine x plus cosine x. Now let's make this equal to 0. Minus sine x is plus cosine x. Let's use the calculator. But even if you take this to the other side, I can understand sine must be equal to cosine. That's around 45 degree, or along the, if this is the unit circle, let's see, the 45 degrees or 225 degrees. That must be the answer. But let's do it in the calculator. I'll show you how we can do it. All you do is type this out. 0 equals minus sine over here x, close the bracket, plus cosine x, and then close the bracket. Here what you need to do is press shift solve and then equal to, the degree is 45 degrees. Leave it in the default mode. Just clear your calculator and use it as x at x. So whatever answer in terms of degrees is much better, because radians, it'll be, when we are solving it, it won't be accurate. If you're using to solve x value, if you know that, then we have to use radians. But over here it's better to use in degrees itself. So now I know x value is 45 degrees. So x is equal to 45 degrees. Now what happens? Sine and cosine repeats. See, they are, if you know the unit circle from before, it's 0, 90 degrees, 180, then 270. If over here we have two things, even over here after 180 degree, it will repeat itself. The coterminal angles. So if you add 180 to 45, it's 225. Even over there, they both are equal. Sine and cosine are equal. Why I'm talking about sine and cosine being equal is because if I rearrange sine to the other side, it's going to be sine x must be equal to cosine x. When are these equal? At 45 degrees and 225 degrees. The values are same. Here it's negative, negative. Here it's positive, positive. So here, that's why we write plus 180 degree times k. K is an integer multiple, like 1, 2, 3 multiples of it. Even, this is 45. Even if you pass 360, again you'll come to the same point. Again you'll come to the same point. So this multiple. So that is the answer. K is 45 degrees. Now here you can see this. Yeah. It's pi by 4. Pi by 4 is 45 degrees, and this k pi means you're adding 180 degree every regularly. So inflection point over here is basically at, what answer we got was 45 degrees plus 180 degrees k, right? Now if you write this in radians, how do we write it in radians, 45 degree? What is 45 degrees in radians? It's pi by 4. I'll show you in calculator. All you need to do is write 45 divided by 180. Now the answer is 1/4, but you have to multiply pi here. Okay, I've not written pi and divided by 180, right? So I've just written this 1/4, but remember it's pi by 4. Just multiply this by pi. So it's pi by 4. Same way, if you do 180 by 180, it's going to be 1. So 1 pi k, and over here it's pi divided by 4. the conversion from degrees to radians. So these are the answers, and that is what we have got. Actually, this must be first, and then you write k pi, that is the repeating interval. So pi by 4 is the correct answer. And if you solve it in degrees, no problem. If your options are in degrees, well and good. If it's not, then make sure you you convert it and then search for the correct answer. This problem, we have got tan inverse x squared. So we need to remember the inverse function. The first derivative would be very simple. It's just 1 by 1 plus x squared. See, if it was tan inverse of x only, it's 1 by 1 plus x squared. But here what you have is already a squared, so there is an extra power 2. Then you just have to multiply with whatever is the extra term. Tan inverse is done. It's the chain rule now. This is done. What is the derivative of x squared? It is 2x. So it looks something like this. 2x by 1 plus x to the power 4. Please remember these two terms. Just don't write 1 by 1 plus x power 4. That will be wrong. Chain rule, this is very important. Now it's done, but now we have to do the quotient rule, not the product rule, quotient rule. Here you can write it as u by v or a by b. It's the same. What you need to do is derive the first term. See, above is the numerator. Derive it, multiply it with whatever is down, minus, leave the first term as it is and derive the below term. Divided by whatever is down is squared. So let me do the double derivative. First, below term is just squared up. Okay, that is done. Now what else? Here, whatever is in the above, you will need to derive it. It's 2 multiplied by whatever is down over here. You have to write it as it is. Minus, now 2x remains. And what is the derivative of 1 plus x power 4? It will be 4x power 3. That is derived, yes, that's it, because it's 0 plus 4x power 3. Now then, let's simplify it, because you cannot just equate this to 0. We have to simplify and get it into reduced form. Denominator is the same. That's fine, let it be there. That is not so important. The numerator is very important because that will be equal to 0, isn't it? Here this 2 is multiplied inside, so it's going to be 2 plus 2x power 4. Then this also is multiplied, minus 2 times 4 is 8. X and x will be x power 4. Don't think 2 is multiplied to all terms. No, they are single term multiplied. So two numbers with numbers. 8, x and x will be x power 4. Now, yes, we can simplify here. It's going to be 2 minus 6x power 4 because it's like 2 minus 8. Because they're the same coefficient, same variables here. And 1 plus x power 4 the whole square. This is equal to 0. So now what we do is we have to equate both the numerator and the denominator. This is going to be the, asymptotes wherever it's undefined. So let's solve both of them one by one. So first I'm going to use the top one. It's going to be 2 minus 6x power 4 is equal to 0. Let's solve it up. 2 is equal to 6x power 4. Now let's divide both the sides by 6. It's going to be 2 by 6 is equal to x power 4. It's 1/3 x power 4. We need to take root radical 4 both the sides. Now since it's 4 is even, you will have plus or minus here. It's radical 4 1/3. That's going to be the roots. Inflection point, that is equal to x. These are the inflection point. What about the denominator? I'll just do it down over here. It's 1 plus x power 4. The square will cancel off, right? See, the square is there. Let's take square root on both the sides. Square root of 0 is 0. So you're just remaining with 1 plus x power 4 is equal to 0. Let x power 4 be there, equals minus 1. This goes to the other side. Now what happens? It's a even number. If it's square, what is square is equal to minus 1? It's imaginary number. Same way, even number, you cannot do that. You cannot, because you cannot have negative over here. It's not possible. So this is not considered because they're imaginary. There's only these 2 points. They are the inflection points. And these would just be undefined points, so you can ignore them. So the inflection points would be radical root 4 1/3 plus or minus. Yeah, they are the correct answers. You can see It's not clearly done, but that's how we do it over here. I've just done it, right? These are the steps, and you don't need the steps exactly. You need just these answers. So it is radical 4 1/3 plus or minus. So here we go. What about this problem? Again, it's similar. There's just fraction rules. We can use power rule. It's simpler. Why? Because it's not product rule or anything. It is just power rules over here. So first derivative is going to look like this. 4/3 x power 4/3 minus 1 plus 4 times 1/3, and over here we have x power 1/3 minus 1. Let us write 4 by 3 x power, it's going to be 1/3 remaining, plus 4 by 3 over here, it's going to be minus 2/3. Now we are derived this again. This is the first derivative only. How about the second derivative? Now see here, the powers are different. We just can't add them up. There are other simplifications. You can remove the common term. What you can do is you can remove this 4/3 out, but still it's the same thing. This is just going to be the constants, So coefficient, they are numbers, so it doesn't matter. I'll write 1/3 down, and now x 1/3 minus 1 plus here 4/3 times minus 2/3, and over here you have minus 2/3 minus 1. So what's going to happen is it's going to be 4 by 9 here, x power minus 2/3, plus here it's going to be 8 by 9 minus 8 by 9. Let me just change the sign. 8 by 9 x, it's going to be minus 5 by 3. So this is all equal to 0. We can't just make it equal to 0 because we need to simplify this. And I can see the numbers 4 by 9. I can remove 1 by 9 for sure. 9 can come out and 4 can come out. So, but still this x's, I need to get them, simplified, like write it in terms positive roots, or I can write it as 1 by x 2/3. Take something out, what is common. Looking at these, I can definitely tell this is common, right? 2/3 is already there in this as well. Let me write it out over here. X minus 2/3. Over here, what's remaining? It's just 2. And this can be written as x minus 2/3 into x minus 1. Why is this? Because if you add them up, 2/3 we just did it up above, right? Minus 2/3 minus 1. If you add this minus 1 over here power, when you add these up, the powers are added up, it's going to be negative 5 by 3. So you can write, you can leave it like this only. Even over here, when you're doing this step, you can leave it out. You can leave or split this powers. You can write this minus 2/3 into x minus 1. Because when they are multiplied, the powers are added, the bases are same. So here I can remove this out, but remember this is negative power, so I'll take it as down, it'll be positive power. And here 1 is remaining, minus 2, and this is gone. See, these two are gone outside. I've removed it common outside. So what is remaining? It's x minus 1. I'll write it as 1 by 2x. This is all equal to 0. This entire thing cancels off. When you take it to the other side, it's 0. What remains is 1 by 2x will be equal to 0. That is 1 is equal to 2 by x. Take this x to the other side. X is equal to 2. So this is the point of inflection. It's 2. So let me just run through this. Here we derived it once. First time was pretty simple. When we derive it for the second time, we are gonna get 4 by 3 times 1/3 x, whatever is the power minus 1. This has happened over here. And then 4 by thirds times minus 2/3. This is minus 2/3 x to the power minus 2/3 minus 1. Next, what we do is we multiply all the numbers. 4/3 times 1/3 is 4 by 9. Here 4/3 times minus 2 by thirds is minus 8 by 9. What about the powers? 1/3 minus 1 is minus 2/3. Here you can leave it like this because I'll just write over here minus 2/3 minus 1. You can write it as same base is the same, minus 2/3 x minus 1. You can write it like this as well. Or if you solve this, if you just put this in the calculator, you're going to get negative 5/3. So now here I need to remove whatever is common term and get the simplified form and make it equal to 0. So what is going out? 4 by 9 is going out because this 4 by 9, this is 9 is gone, but 4, instead of 4 we have 8, so 4 times 2 is 8. 4 goes, see, it's basically 4 by 9, and we have 8 by 9. So here 4 by 9 remains, minus here 4 by 9 times 2. Why? Because 4 by 9 times 2 is 8 by 9, isn't it? So that's why I can take 4 by 9 outside, and you're remaining with 1 minus 2 for the numbers. Then here we have x power 2 minus 2 thirds, which is equal to x power minus 2 thirds is basically 1 by x 2 thirds itself. I hope this is clear before itself. Now here what happens is, instead of writing minus 5 by thirds, we know it was minus 2 thirds and minus 1. So I split it out and I can remove these two common outside, and that's also gone. So only thing that's remaining is 1 minus 2 by x. And then 1 minus 2 by x equals 0. I've solved it up over here. It's very simple. Minus 2 by x to the other side becomes positive 2 by x, and x to the other side, it's already 1, so it'll be 1 times x, that is 2. So the point of inflection over here for this particular problem is at 2. Here we can see the answer as well. This is the answer. It's written 0, 2, but the actual thing is 2. From here we need to equate it to 0 and then do it. So that's how we do it. Since there is no need of writing anything, you can, do your own methods. But this is pretty long because there's no shortcut or direct method. But I hope this is clear. I hope in the exam it'll be an easier problem rather than this. Now here it's just the product rule, and it's not that difficult because we have e exponential are very simple to solve. So the first derivative would be, now it's if it's a and b, it is a derivative b plus a b derivative. This is the product rule, a simple rule. Comparatively it's simple. So x derivative is 1 e to the power minus 4x, plus we have to write x, that is as it is, because over here first time we derived x, that was 1. Now second time we write x as it is and derive b. What is happening here? It'll be e to the power minus 4x itself, but don't forget the chain rule. Whatever is up, we also derive that. It'll be minus 4. So now let's simplify this. F derivative of x, we'll get e to the power minus 4x minus, see, 4 times x, e to the power minus 4x. Now I'm not going to leave it like this because again product rule and everything. Let me take these two terms outside, because even if I don't take, I'll have a product rule here. It's going to be complicated, but I know these two are same. So e to the power minus 4x. So what is remaining? 1 minus 4x is remaining. Okay, this is also a little bit complicated now, I realize. Now we have to double derive it, and it's going to be product rule again. So first time when we derive this, it's going to be e minus 4x times minus 4 multiplied with the second term will remain same. Now I just derived the first term which I got over here, second term same, that is with b, plus, did I write? Yeah, we have written plus, then minus a chain. Now this term I'll write it as same, e minus 4x, but what happens is I derive the second term only. It's going to be, see, this is 0 minus 4 because x is going to be 1, right? It's going to be minus 4. This is the answer. And now we need to rearrange it how much we can. So it's over here, it is minus 4 e to the power minus 4x multiplied with 1 minus 4x. And here also it's minus 4 e to the power minus 4x. So we have just written it over here. Now we can take this two common outside, though they are, this is like a x minus a. So I can remove a outside. It's going to be x minus 1, isn't it? But it's minus minus, so I'll just remove minus also outside. It's going to be plus. So it's like minus a. Imagine this is minus a. This is x minus a again. So minus a is removed outside. You're remaining with x plus 1. So here I'm going to remove minus 4 e power minus 4x outside, and you're remaining with, this term is gone, so you're remaining here with 1 minus 4x And this is also gone, so it's plus 1. I hope this is clear. Look at this. This term is considered to be minus a. This is again minus a over here, and you have x. And this is a single term minus this term. So I can remove 4e power minus 4x as common term. I can remove a outside. You're supposed to remain with, I'll use a bigger bracket because that is removed outside. So this is the bigger bracket. Your minus a is written out. So what's remaining is x. X is 1 minus 4x plus 1. Next, here what happens is you can simplify. This is going to be minus 4e to the power minus 4x. What happens here? It's 1, 1. It's not going to cancel. Sorry, my bad. It's plus. So 1 plus 1 is 2 minus 4x. That's remaining. This is all equal to 0. When you take this to the other side, this all dissolves. Now, what about this? It's going to be 2 minus 4x is equal to 0. Let's solve it up. It will be 2 is equal to 4x. Divide both the sides by 4. It's 2 4 is equal to x. That is 1 by 2, right? 2 by 4 is half. So the critical inflection point must be at half. And yes, that's the point. So this is the actual method to solve, and you need to solve it, guys. You need to double derive. There is no shortcuts because your calculator can give you one derivative. The graphing method will not give you enough information. It's very, very difficult to find the inflection point. And maybe some problems, yes, but majority of the problem, the graphing mode 7 method will not give you the inflection point. It doesn't, because imagine this is the inflection. See, inflection point is somewhere over here. How would you know? It's just decreasing. If it's increasing or decreasing, critical numbers, yes, can be found out from graph, but not this inflection point. So it is very important for you to double derive it and then get the answer. I hope polynomial problem come, they are simple to solve. If it's such problem, you need to be careful while deriving it twice and then equate it to 0 over here. They have removed common terms. Any method we do, as long as you've done it correctly, it's fine. Over here, this is the answer. They have removed another 2 outside, so that's why they've got this answer. But what I have done is also absolutely correct. The same answer we have. That is the end of this question. I hope it is clear. If you have any doubts, please consider rewatching the video or posting your doubts in the comments. I hope you all will head on to the next video.